Hey there, this is video C13, and we are now going to talk about, I guess it's a subset of permutations, and it's actually one that, well, I don't know how to use the fundamental accounting principle for. I'm sure it's a subset somehow, but, and actually it's a really cool formula. I'll show you in the next page. It's really easy. You just got to remember when to use it. So we're talking about still going to order things in arrangements, but not everything is different. We're going to have some repeats here. But I want you to figure out how many different ways can you arrange the letters in the word car. Go ahead and figure that out. Pause the video. And you can also write them all out. Okay, you know what? I'm going to do the math first because I like doing the math first. 1, 2, 3. So if I'm going to arrange this, there's 3 letters. And then there's going to be 2 letters. 1. I know there's going to be 6. So I can do C-A-R, C-R-A. Then I can do, R-A-C. And I can do R-C-A. And then I got to start with the R. Nope, I'm going to start with the A. A-C-R and A-R-C. I knew there were 6 and I know I'm done. Okay. So those are all my different combinations. And you're welcome that I didn't choose a word like uncopyrightable or something crazy like that. Nice and simple. Okay, how many ways can you write the letters of the word mom? M-O-M and M-M-O. Now, O-M-M. So I'm starting with my second letter. But because here, I started with my first letter and then I flipped my letters. I'll go this way. And then I went to my second letter and I wrote the other 2 and I flipped. But these ones are the same. So arrangement wise, that's only going to count as 1. Now, if I go to the last one, well, this is my last M, but it's exactly the same as my first M. Okay, I ended up with, these ones are the same as that one. Okay, so what screwed that up? The fact that we had repeats. That's what this thing is all about, is when you have 2 or more elements that are exactly the same, the regular permutation thing that we were doing before isn't going to work anymore because they end up looking alike. And in fact, I think you've got 1 arrangement there, mom, and then MMO. So that's a second different one. And this would be the third one. So these 3 are the only choices. Everything else we generated is a duplicate. And order matters. Now, would it make a difference if I wrote the word like this? What do you think? Yeah, because then you could have a little m and a capital M, and then they like this, if one of those was, whoopsies. Let me just go here, O-M-M. See, those would look different, but because of those capitals, it's messed up. So the answer is yes. Then you probably would have the 6 that you were supposed to have. Now, try it again. I'm going to give you a hint. There is a formula for this. I'm just not telling it to you yet. I just want to show you the difference. All right, so we got mode. We're going to calculate the number of arrangements. I'm not going to write them out. we got 4 letters. So 1, 2, 3, 4. That's 4 times 3 times 2 times 1. That gives me 24 different arrangements. Okay, but when I got move, I've got M, O, O, O. Those O's all look identical. So the only thing I can do is go O, M, O, O. Just move the M. What are the other 2? There's 2 more. Right. O, O, M, O. And O, 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 M. So we got 24 choices here. We only have 4 here. So there's a distinct difference in the number. Okay, and then at the bottom it says, if there are identical elements, repeats in a permutation, there are less arrangements. And if everything is all different. And I'm going to jump ahead. I'm going to show you what the formula is. Okay, so the formula, we'll just come into the next video, but that's okay. Is n factorial over r factorial s factorial t. And I think I put dot, 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 where n is your total number of letters or whatever you're arranging. So in this case, I'm using the word mom. There's 1, 2, 3. Don't care about repeats. So this is going to be 3 factorial. And then what actually happens is we have to adjust or divide by the ways that these guys, because they're exactly the same, that they're creating duplicates. So this RST stuff on the bottom is for your duplicates. And in this case, I'm going to go 2 factorial. And that's because there are 2 m's. Now, if we do 3 factorial divided by 2 factorial, we get 3, which is what we figured out. Because we said that these are actually the 3 different ones you can get. You can have the M in the, or sorry, the O in the middle, the O at the end, or the O at the front. So let's look at this one. N factorial, R factorial, S. And these letters, you just add enough so that you have enough repeats. So we've got 1, 2, 3, 4. And we have 1, 2, 3 O's. I'm going to put an O underneath so I know what that's for. And if we go 4 factorial divided by 3 factorial, you already know what that is, right? Because really you're going 4, 3, 2, 1 divided by 3, 2, 1, and that's going to be 4, which is what we figured out there. This formula would work on this one, but there's no repeats. So why would you bother? All right, anyway, there's our handy dandy formula. And even though there's an S and a T, I don't need them because there was only one letter that repeated. All right, that is the end of the video, but the next one, because it is super easy and it will help you with this.